So I'm on the bottom of page 63 here, and now we're going to talk about how to take that arc versus capital A arc knowledge and apply it to finding angles whose values I already know using a step-by-step process. You'll notice just above these examples here, I did give you this step-by-step process, but I'd like to kind of write it down so that I can explain it as I go. My notes that I'm about to write may differ slightly, but I wanted you to hear it from me. So we're going to start with a quadrant. And the quadrant specifically that I'm looking for is going to vary from question to question, but I'm going to use example 8 as my key here. I'm looking for the quadrant where a cosecant would be negative. That's the quadrant that I would like to begin with. Now, keeping in mind that a lowercase a has multiple answers, the next thing I need to point out to you is that they can't ever ask you to come up with all of them because there are infinitely many of them. So I will caution you that the biggest mistake you're going to find in this particular series of questions has to do with this piece right here. When I give you a lowercase a arc function, I've got to give you a range of angles within which I'm looking for answers. I can't ask for all of them because there are infinitely many. The biggest screw up people make is they go outside the range because the Regents is notorious not for asking for 0 to 360, but say 0 to 180. And a lot of times they'll make that 180 not be inclusive. Means 180 can't be your answer. It's not in the domain that they have given you. So you need to pay real close attention to where they're asking for answers. Now, I, as a general rule, will pretty much stick to 0 to 360, one full circle inclusive, but watch the Regents because they're scary, tricky like that, and they're really detail-oriented, and they want to know who else is. So look for that detail and make sure you're paying attention. So what quadrants is a cosecant, think about sign, negative in? 3 and 4. So I want to write that down. And essentially, I want to write that down so I don't lose sight of it. Because if I'm going to go from 0 to 360, that means I should end up with 2 answers. And one of them should be a number that lands between 180 and 270, a third quadrant angle. And one of them should be a number that lands between 270 and 360, a fourth quadrant angle. Next, now that I've got that quadrant, the next thing I want to do is I want to go to my calculator and I want to second. And I'm just going to write trig, but it's going to be second whatever function or its reciprocal that you're dealing with, you're going to second it. Now I chose number 8 on purpose because there isn't a cosecant button. So one of the hard parts about inverse functions is realizing that what you're looking at there is not an angle. What you're looking at there is the answer. When I'm dealing with reciprocal functions, what part do I reciprocate? Since it's the answer we reciprocate, and this is the part that gets a little tricky, that is the answer. I got to reciprocate before I go to my calculator. And so inverse reciprocal functions are just a hair harder, and I wanted to make sure I started with that so you had time to digest it. What I'll actually be doing for this example number 8 is typing onto my calculator second sign, but not of -2. I'll be typing in the second sign or the inverse sign of -1/2. Did you see that reciprocation happen there? Now, the next issue that you're going to be dealing with, and it's going to be a little issue right now because we're going to fix it, but a much bigger issue when you take the test next week, is you got a funky looking answer. And I'm going to tell you you should have gotten a nice pretty answer. And if you got a funky looking answer, it's because I'm looking for an angle in degrees. And you, my friends, are very likely still in radians. So put yourself in degree mode and try it again. And when you try it again, I'm very hopeful that what you're seeing there is a -30. Nice, pretty number. Now, you could have done that in your head, a little bit of math. This is the exact value whose answer is 30, and what sine function has an answer of 1/2? 30. And since the sine function has an answer of 1/2 at 30, but I want it to be negative, what the calculator is saying is take that reference of 30 and shove it into the fourth quadrant. So it's that fourth quadrant piece. Now if I go back to my notes over here, one of the things I could show you is that in very much the same way back when I first taught you the trig functions, I said the quadrants break up horizontally like this. When I'm going through the arc graphs, they break up vertically like this. So that this is still quadrant 1, and going northward, this would be quadrant 2 in here, and quadrant 3 in here, and quadrant 4 up here. But those functions kind of go northward in order. So 1 would be down here, 2 would be here, 3 would be here. This is the fourth quadrant right there, which means that the inverse sine function is always going to be an angle that either lands in quadrant 1 or in quadrant 4. Now why is that relevant? Because it means it's always going to be an acute angle. If it's in the first quadrant, it's going to be acute and positive. If it's a negative inverse that I'm calculating, it's going to be acute and negative. That's exactly what just happened. Now I'm not done, and I can't be done because that negative answer doesn't fit where I wanted it to be. Remember I said I'm looking for a number between 0 and 360. Those are all positives. So now I need to use this negative 30 to help me find my answers. This is a means to an end. It's not my answer. Rach, you okay? I'm getting overwhelmed? All right, so now I'm going to draw an axis. And I said I was looking for answers in quadrants 3 and 4. So I'm going back to my bow tie. And I'm drawing triangles in quadrants 3 and 4. David?
Your answers are going to be in 3 and 4? Or are you going to choose?
Both. I'm going to have an answer in 3 and another answer in 4. Anybody want to speculate what the reference angle I'm going to put in those two triangles is? That's what the 30 is. This 30 was my reference. This negative meant put it in quadrant 4. Check. So what am I going to put for a reference over here? Same thing. My job at this point is to figure out the two angles. It's easiest to do them one at a time. The first angle I'm looking for starts in standard position and ends right here. And again, it's easiest if you visualize it, because I'm going from 0 through 90, through 180, and then 30 degrees more. What is that third quadrant angle? It is 210. Does everybody see how I got that? The second angle that I'll be looking for is going to be an angle that also starts in standard position, but this one goes through 90, through 180, through 270, and it's almost going to hit that 360, but there's a little gap, and that gap is a 30-degree gap, which means I'm at 330. That is the step-by-step process. So step 3 was draw and use the reference that you got in step 2. And step 4 is calculate each of the unique angles one at a time. And you should end up with 2 separate angles. All I have to do for a capital A is type what I see and make sure my answer that I see on my calculator screen is exactly what I write. So I'm going to type into my calculator screen second sine 1/2. My calculator is going to say 30. I'm going to write down 30 and move on to question 2. If the answer that I'm looking for, as if in example 3 were a negative, and I happened to not have a calculator, I would be thinking, what is the angle whose sine is 1/2? And where will I find sine answers that are negative? The answer whose sine is 1/2 happens at 30, and negative sine happens in quadrant 4. So I'll call that a negative 30. And that's what your calculator would have told you. Negative answers for capital A are fine and dandy. If I go to do number 2, the arc tan of 1, I could do it in my head by saying, I know my answer is going to be in the first quadrant, and I know the angle whose tangent is 1 is a 45. And if I were to type second tan of 1, my calculator would corroborate that. Still good? if I were to type into my calculator the second sign of rad 3 over 2, my calculator would be thinking quadrant 1 because this is positive, and the angle whose answer is rad 3 over 2 is a 60. So my calculator would say 60. Does everybody see where this is coming from? You're going to have a calculator. I can do it without. Arc cos of rad 2 over 2, quadrant 1, reference of 45. Probably the hardest one here, arc cos of rad 2 over 2 that's negative is 135. Means go to quadrant 2 and use that reference of 45, but your calculator would tell you that if you just typed what you see. Still good? When you're doing algebraic compositions, everything we do comes back to algebra. So this is compositions of functions. Let me see if I can't reframe this for you. This is the angle whose cosine is -1. Emphasis on it's an angle. There is some angle whose cosine is -1. I want you to find that angle and take the sine of it. So just like we did in compositions, we're going to do the inside first and then the outside. Now these I would strongly encourage you to not use your calculator for because frequently they are exact values. So watch how I'm going to do this. When I see these whole number answers, I'm going to be thinking of my unit circle, remembering that cosine is the x coordinate. What angle has an x coordinate of -1? I think I hear it. It's 180. It's right here. This is the coordinate -1, 0. Can everybody see it? 180 degrees. That means that the angle whose cosine is -1 is 180 degrees. Still good? Okay, now I want to take the sine of that same angle. If cosine is the x coordinate, then the y coordinate is 0. And I'm done. Moving right along. In this one, I'm going to do this without a calculator, and I'm going to use my bow tie trig to do it. The angle whose sine is 4/5. Positive 4/5 means draw it in quadrant 1. Your angle would be right here. Its opposite side would be a 4. Its hypotenuse or radius would be a 5. That means its adjacent side would be a 3. This is the angle. I have no idea how big it is, but can I take its tangent? I can. What would its tangent be? Here's the angle. Its opposite side is a, and its adjacent side is a 3. 4 over 3 is my answer. It helps a lot to think about the relationships between these angles. Watch this next one. This is two angles, or infinitely many, however you want to think about it. But the angle that I'm thinking of here has a tangent of 1/3. Whatever this angle is, and there will be infinitely many of them, their tangent is 1/3. So what would the cotangent of the same angle be? 3. Did I need to do any math there? All I needed to know was that this thing right here was an answer I was looking at, and they were asking me for the reciprocal answer. Do you see it? Okay, let's try another one. This one is a little bit harder. This is an arc cos of -24/25. It's a capital A.
Good afternoon. I just have one announcement.
It's a capital A cosine, which means it's only going to happen in one quadrant. And we just finished saying that cosines will happen negatively in quadrant 2. Do you see what I just drew? Now I'm going to use my SOHCAHTOA trig, and I'm going to label the adjacent side with a 24 and the hypotenuse with a 25. And one of those two is a negative number. Which one? The 24. And I know that because it's going left. Now I'm going to use the Pythagorean theorem to find the third side. This is a triple. Anybody know the third side? It's a 7. Nice job. And now I have the angle, and I'm done with the inside. Essentially, I used all of this stuff to draw the picture. Now take the tangent of that angle. 7 over -24 is my answer. And I am done. The algebra with these things is the hardest part. Good luck on tonight's homework.